array. Next section is programming with arrays. So this is basically some examples of ways to use arrays as you're writing your programs. It doesn't have any real new syntax or new features of the language. It's just ways to use stuff that you've learned already. First thing we have here in example 7.9 is the partially filled array. So we talked in one of our self-test exercises about passing a smaller number than the actual size of our array to a function. And this is an example of using that to partially fill an array. We don't necessarily need as many elements as we have declared. In this case, they're taking some number of golf scores, averaging them, and then figuring out how far each score is from the average. So first thing they do is they call the fill array function, which has, in addition to the array and the size, a new field called number used, which is a reference parameter. And basically, it's going to keep adding numbers to the array until either you give it a negative number indicating that you're through, or it runs out of actual space. And then we store the number that was used in that process, and then use that for the show difference function as if it were the size of the array, even though it may be less than the actual size of the array. That's a fairly common way to use arrays. The next example, display 7.10, is an array search. The fairly simple linear search through an array for a particular value. It's going to stop as soon as it finds an element that matches the target that we're searching for. If you wanted to, in addition to having the array, the number using the target, you could have a starting point, so that if you found one element that matched, you could then start at the next element and keep looking for the same target value. But this is as written, it's a simple search that stops when it finds the element that it wants. The next example, 7.12, is a sort routine. There are actually lots of ways to sort sets of numbers, and different ones are useful in different situations, depending on characteristics of the elements you're trying to sort, how many elements you're trying to sort, and things like that. The type of sorting algorithm they're using in this example is called a selection sort. It basically, starting at the beginning, goes through and finds the smallest element and swaps it with the first element. And then it does the same thing, except it starts at the second element, and then the third element, and so on until it has gone through all of the elements n minus 1 times, which is n is the size of the array. But each time it has a smaller subset of the elements to go through, so that makes it fairly efficient. Since once it has found the correct location for the smallest element, it doesn't need to ever look at that element again. So, the next example acknowledges the fact that selection sort is not the only way to sort an array. And so it's another sort algorithm. This one's called the bubble sort. Basically, what the bubble sort will do is move the largest element to the end of the array one step at a time. And they have an explanation of that on page 421, 422. It's fairly useful, simple sorting algorithm, particularly for small numbers of elements. So they've given you two sorting examples so you can compare how they work, and maybe someday you'll come up with a new sorting algorithm that works especially well for a data set that you've got. Self-test exercises, page 424. Let's see, is it Ms. Hargrove again? Number 17, write a program that will read up to 10 non-negative integers into an array called number array and write the integers back to the screen. This is just a simple program and you don't need to write any functions, just the basics.
So from the beginning, they include IOString.
Okay. Let's start from here, basically. Okay.
We'll have a constant integer. I guess
Did you say constant?
yeah, constant.
Okay. And
that would be the size equals 10.
okay.
You'll ask to have the right numbers, so count, C-O-U-T. up to 10 numbers. So non-negative, so, put up to 10 non-negative numbers because the ending was negative. And line. CM. Be next.
All right, Ms. Hargrove has gotten us started. Mr. Rahim, how would you continue at this point?
Seeing next. We haven't declared any variables.
Okay. Mr. Gear, would you like to declare some variables for us?
Int number array, size, bracket size. Then we need int next. And index equals 0.
Okay. Mr. Wilson, do you have any input?
Still thinking about it.
Okay. Probably going to need some kind of a loop, wouldn't you think? Anybody like to suggest a type of loop? A for loop, okay.
While
Oh, while loop, okay. While what?
next is greater than or equal to 0. And index is less than size.
All right, well, anybody have anything you'd like to add? Or would you like me to finish this program for you? Anybody know what to do next? All right,
Array index.
I'm sorry,
Number array index.
number array
Index.
index equals next. All right,
And then index equal.
all right. And then to output it, I'm going to go ahead and make another. And there's one more problem with this. Next doesn't have an initial value. I'm going to use a priming read here before my loop.
Let me run that and see what it does.
Sure. Okay? That what you expected? Um, so we kind of jumped in writing the code without writing a separate algorithm, which may not be the best way to write the code. Sometimes it's helpful to write out the algorithm, especially if you're not as familiar with the programming language you're working with. But you know, if you use a language for a while, you can get used to the rhythm of it and write your algorithms directly in the language sometimes. Let's talk about the number 18, which is very similar. Write a program that will read up to 10 letters into an array and write the letters back to the screen in reverse order, and use period as a sentinel value. And we're going to call the array letterbox. So what would it take to change this program to work for project 18?
Instead of an array, we need a character array.
Okay,
Name letterbox.
all right. So let's say char letterbox. And next will have to be a char as well. And
Why not equal to period?
next not equal period. They want it to be output in reverse order. So now we need to start at the far end, right?
Minus minus instead of plus plus.
All right. All right. So once you get the hang of working with arrays, uh-oh, something went wrong. I didn't get my first letter. What happened?
You have index 1 instead of index 0. The index should be greater than equal to 0 instead of greater than 0.
Ah. Okay? Make sense? Now you know all about working with arrays, right? Well, not quite. Let's go on to the next section, multidimensional arrays. Multidimensional arrays in C++ are a little different than they are treated in some other languages. In C++, a multidimensional array is implemented as an array of arrays. And so you could have an array of arrays of arrays of arrays of arrays of arrays of arrays of whatever the base type is. It's eventually always a base type. So we're going to look at the simplest multidimensional array, which would be a two-dimensional array. And they talk about two-dimensional arrays. You can think of it kind of like a spreadsheet with rows and columns. In the two-dimensional array program display 7.14, we have an array with two axes, and that's students and quizzes. So in this case, let's see, the students are the rows and the quizzes are the columns. And in this program, we have the user enter a grade for each quiz for each student, and then the program is going to calculate the average of all the quizzes for each student and the average of all the student scores for each quiz based on the two-dimensional array that we created of students and quizzes in the array grade. So grade is an array of arrays of integers. So index 0 for student 0, they call it student 1 here because they're being all English friendly, is going to have an element that is the 3 grades for the 3 quizzes for student 0. Element 1 is going to have an array of 3 grades for the 3 quizzes for student 1 for the second student, and so forth. Because it's an array of arrays, the syntax is always the name, square bracket, no punctuation. In some languages, they use commas, they use whatever other punctuation to indicate array elements. In C++, you just get sets of brackets. So we're going to use the two-dimensional array sample in our homework this week because the homework is going to be the airplane seating chart. What project is that in this book? It's 11 on page 445. All right, project 11. Write a program to assign passengers seats in an airplane. Assume a small airplane with seat numbering as follows. And you'll notice the way they've numbered it, we have 7 rows, numbered 1 through 7, with 4 seats in each row, A, B, C, and D. So what does that mean? Well, you're going to have an array of arrays of some type of value, and the value is going to need to be able to indicate whether the seat is occupied or not. And there's at least a couple of ways of doing that. I've had students use a two-dimensional array of Boolean, where true means it's occupied and false means it's not occupied. Or you can use character and just put the actual letter of the seat in there and change it to an X when it's occupied. Those are a couple of good ways of doing it. You may think of some other good way. But let's talk about how we're going to resolve this project. So is this assignment 7? And instead of number of students and number of quizzes, we're going to have what?
Rows and seats.
Okay.
7 rows and 4 seats.
Airplane rows equals 7. Airplane seats equals 4. And what the instructions tell us are that program should display the seat pattern with an X marking the seats already assigned and letters indicating what seats are not assigned. So 1A, you'll notice, is marked with an X. 2B is marked with an X. And 4C is marked with an X. After displaying the seats available, the program prompts for the seat desired. The user types in a seat. And I'm going to ask you to allow the user to enter their seats just like they're listed here. If I wanted the first seat on the first row, I would ask for seat 1A. And the second seat on the second row would be 2B. All right, so the user types in the seat, and we update the seat display. This continues until all seats are filled or the user signals that the program should end. if the user types a seat that is already assigned, the program should say that seat is occupied and ask for another choice. So if we're going to display a seating chart, probably need a display seating function. Display seating function is not going to update the seating chart, so it can be a const. Anybody come up with any answer, any reason, any rationale for choosing a particular data type? Who has a preference?
Characters, because we're going to use one character.
All right. There's a seating chart, so I'm just going to call it chart here. When we have a multi-dimensional array, we still don't fill in the first dimension because the first dimension can still be anything. But we have to fill in any other dimensions because we have to know those other dimensions in order to be able to tell the size of each element of the first dimension. So we know it's characters, but each element of the first dimension is going to be 4 characters because that's what the second dimension is. And I'm going to go ahead and have variables for rows and seats. Okay, what would be the precondition for display seating?
Display 7 rows with 4 seats letter.
That the precondition would be my chart has to be initialized to have something in it. What does it need to have in it? If we're using characters, it should have the seat letters and, well, not numbers because the numbers are the rows. We only have a single character, so all we can put in is 1 character's worth of data.
So ABs.
A, B, C, D, A, B, C, D, A, B, C, D, A, B. Unless the seat has been assigned, right? In which case we would have X. So seat values have been initialized to the seat letter or X, which indicates seat is assigned. Post condition, the seating chart has been displayed to the screen, right?
Need to add another function to initialize the seating curve.
All right. That's going to be basically the same, right? The precondition will be nothing. All right, and so we're going to need to write that function. All right. So our array, we're going to need to create an array here. It's a character array, right? That's going to have
Max rows, max,
max rows,
or airplane rows.
airplane rows, airplane seats, and first thing we're going to do is initialize. The next thing we're going to do is display, right? Need an initial display. Okay, so how are we going to initialize those seats? What did they do in our example program? They had to do something to go through all of the seats, right?
For int x. Delete.
All right. I'm going to call mine row. Row equals 0. Row less than rows.
The,
Row plus plus, right?
would that be airline rows? Like those?
I gave myself
Okay.
a parameter for that. Okay, that'll go through all the rows. Now I want to go through all the seats on a row, right?
We could use the constant variable there, right? Instead of just the rows.
We could, but that would limit us a little bit, although having to use it here kind of puts a cramp in it anyway. We're going to learn later on how to make things more flexible, but for now, giving ourselves enough parameters makes it a little easier. I passed those constants in the appropriate argument, right? Okay. I just want to set the seat equal to the letter value that corresponds to its number, right? So seat 0 would be the letter A. So how am I going to do that?
Static text character.
Okay. Where am I going to put that?
After
In other words, I'm doing a static cast on something to get a result. The result is going to be A, B, C, D. Where am I going to put that result? Ms. Hargrove, any idea? Mr. Rahim? No? Mr. Wilson?
Well, we gotta change seats from integers to characters, right?
Right. Do you know any way of doing that? I mean, we already had the suggestion to do a static cast char. if we just do that with the value 0, what character is that going to give us? Does our ASCII chart go down to 0? No, it doesn't. I think 0 is the null, though. We wanted to get to A. What do I say about the character functions? If we look in Appendix 4 at the character functions on page 1022, toUpper returns an integer. That's integer that it returns is actually the decimal equivalent of the ASCII code value for that, for the uppercase character that we give it as its argument. Like that, right? Except that would just always give us A, right?
So plus.
What's something? What something would that be?
We need another variable.
If 0, if seat 0 is letter A and
Yeah.
seat 1 is letter B,
Plus row
not row,
per seat.
seat. And we need to store that in our seating chart. That makes sense? You understand how we got there? All right, so we got a squiggly line. What's the problem? Expression must be a modifiable L value. What does that mean?
Means we need to add a library.
No? Anybody have any idea what that means?
We have to change it to const, don't we?
We have to change it to not be const because const means we can't change it, right? We're trying to change it. We can't change it if it's const. Initialized seating has to be able to change the seating chart. And I should go up here and change this one too, right? All right, so we've initialized our seating by going through every row and every seat in that row and setting it to a letter value that corresponds to the seat. And now we need to figure out how to do the display seating chart part. That's going to be pretty similar, isn't it? Except this time, instead of setting something, we're going to be outputting something. And in fact, we're going to need to output something for each row also. So when we start a new row, we're going to output a row number. I guess I don't need to do that because I only have 7 rows, right? This time it's already characters, and I just need to output them. All right, so I initialized it. Oh, one more problem.
You did. +1.
+1. All right. Since our numbering system starts with 1 instead of 0,
There. See how row +1.
I can just do a row +1 here instead of. Okay. All right, so we've covered initializing our multidimensional array and displaying the contents of our multidimensional array. What's left?
Here you start turning A's, B's, and C's to X's.
Okay, you're going to have to accept input from the user that says what seat they want, whether it's 1A or 6B, or what happens if they ask for 8E?
We need to tell them that's an invalid row.
Okay, you need to validate their input, make sure that they haven't input something stupid. If they haven't input something stupid, in other words, the row and the seat fit in between, in the range of valid rows and seats, you need to check the array to see if the seat they asked for has been assigned yet. If it has been assigned, you need to say, oh, that seat's already been assigned. Please try again. If it has not been assigned, you assign it by changing that letter to an X.
Do we have to use an X? I know that it says to use an X, but like asterisks stand out more than X. So can we use an asterisk?
If you explain to me that you have chosen to use an asterisk instead of an X for aesthetic reasons, then I will accept it. Otherwise, according to the assignment, it's an X. So change the letter to something else that indicates what it is. Now, so how will you know if it's already been assigned?
Because it won't be a B, C.
Well, it will be whatever value you've chosen, whether that's X or something else. So if it's an X, then you know that seat has been assigned.
Do we need to put something in there so if we enter something and it's already been assigned, it will tell the user? Like, since we're changing the array,
You're
that's gonna
changing
be
the
an
array.
X.
When they
Do we
enter,
need to output, like if they input, let's say they do 7C and then later on they do 7C again,
right?
do we need output that says if the seat's been assigned, please choose
Yes.
another seat?
Seat 7C has already been assigned. Please try again. Please choose another seat. Not only do you need to tell them when they try a seat that's already been assigned, you'll also need to indicate when all the seats have been filled. So if all the seats have been assigned now, you need to stop boarding. No more, we're not taking any more reservations because we filled the plane up. Or if the user decides it's time to go without having filled the plane up. All right, so you got about 30 minutes of class time left if you would like to start working on that. And if you have any questions today, I can try and help you answer those. Otherwise, if you get home and you've come up with a question, send me an email with your source code, and I will try to answer your question then. But first of all, any general questions before I end the lecture? All right, if not, that concludes the lecture for this evening. We're into lab time. If you can either stay here and work on the assignment or go home, and the assignment will be due next week. All right.